First of all, the very first line here gives the NIST, the US NIST definition. It's a very good, very comprehensive definition that reads a model for enabling ubiquitous, convenient, and so on. To distill from that some characteristics, we see the key phrases: on-demand self-service, broad network access, resource pooling, and so on. We can all read that. There are different service models and deployment models, but I really like a definition given by Joe Wyman. Summarizes what we see as the key characteristics in an easy-to-remember acronym. So it's common, it's shared, location independent, you can access it anywhere, online. Internet is a very key part of it. Utility, pay for what you use, and on-demand, IT service. I really like that, and I find it easy to remember and easy to explain to other people what this is all about. Internally, we are even simpler minds, and I just want to see it as a way of sharing, how by sharing resources and pooling or aggregating demand, we'll realize performance and cost benefits in IT service that are accessible anywhere, anytime, in any size, and also a key part of it is self-serviced. So in everyday life terms, we can look at it as probably a corn-operated laundromat. You go there, you have machines. I mean, that's a very good example of a cloud model. So now, in a lot of these attributes about available resources, share, and so on, we probably see it for a long time already. For people who've been with the computer longer, going back to the mainframe data center days, many of the experiences were very similar to what we tout as the benefits of cloud computing today. But what's really unique about the current generation of cloud computing are that for most users, they basically see unlimited resources available, can be very quickly provisioned without having to wait for the operator to respond, to answer your call, and that sort of thing. Now, what are the advantages and disadvantages of the cloud standards? I think we heard a lot about this earlier today, and we'll give you, I'll here briefly describe how we see it. There may be a lot of overlap with earlier messages. A set of common standards, we can implement and adopt this new technology much more quickly. And it's very easy adoption. Because of easy adoption and low cost of adoption, that would also promote its usage. So as the size of the usage population gets bigger, there will be even larger economies of scale. So it's a self-growing. I guess George Soros would call this reflexivity. It's self-reinforcing. It enables portability, interoperability, and peering, which would be very difficult between clouds. Within a private cloud, pretty much each company, each big user would have set its own standards, and so those are not issues, but when you work with inter-cloud, between clouds, you like to have standards, otherwise they don't match. Each party is happy with its own standard. So you go forward in time for a period. Now comes a common standard. Those people who had adopted the right standard, they are very happy. But the ones who had chosen the wrong standard, they would actually have to incur a higher cost of adoption. And so this is a disadvantage for some people. And because of that, actually, it would deter some people from using it today for fear that they may pick the wrong one, pick the wrong horse. Also, a single standard is great, has a lot of advantages, but it also may degrade performance of some niche applications. People with no constraints, they can optimize their entire system, hardware, software, applications, data, etc., to achieve the best performance for a special application. And those may actually degrade in performance when you force them to switch to a common standard designed for another sector. It also may kill superior latecomers. Once a certain standard is adopted and the market size has grown to a certain scale, that makes it very difficult for a new entrant, even if it's technically far superior. We've seen that in many other sectors. Now, some characteristic of the standards. We think that the standards really, it has a big prize dangling in front of it. It's certainly a booster for the existing products. So if three parties are competing and Party A's version was adopted as the standard, Party A really, he will win really big. He will be so far ahead of all his competitors. Some government organizations may realize benefits by collecting license fees, by certifying that the other players are in compliance and so on. But this is a very high-stakes game. Winner takes all. We've seen that in Betamax versus VHS, Lotus 123 versus Excel, and the countless other examples. For that reason, the big players who have the resources and wherewithal to do so, they would like to drive the standards. They like to push their own standards, because if they win really big. But it's a game for the rich. It's very costly to get a seat at the table. You have to be willing to fight a protracted battle. But the prices are there. High risk, high return. There are also challenges. At this moment, there are probably too many competing alternatives, which is not, it's okay. But bottom line is, if there's only one supplier out there, then that would be the de facto standard. If there is one version that's superior, that's obviously superior to the others, also there will be no protracted battle. People will fall in line fairly quickly. However, if there aren't any single superior alternative, then the battle may go on for a while. In the end, we may end up with multiple standards. They may not, the goal of a single standard may take a long time to realize, but that may be okay. I mean, if the market is segmented into large segments, maybe there's a Chinese standard, a one for Europe and North America. When you have a large enough market, you can probably sustain an internal standard. However, if you need to communicate, you want to do business with the other sector, then a single standard, at least easily compatible standard would be nice. So with that as background, we look at ourselves. S3 has a relatively small team effort. We have to pick and choose the ones that we can play in. We can't do everything. So we decide that we are not a big player, we're not a big vendor, we're not a big market driver. But we like to be a smart buyer. We like to offer advice and tools and so on to help others to be smart buyers of this technology. They can enable rapid adoption of established standards and minimize the conversion costs when one is established. So our plan is to stay engaged as an active observer. We'll spend efforts in following trends of the major standard candidates, the Chinese standard and international standards. We'll evaluate peering and interoperability issues, feed our findings to the major parties. For example, our CTO is assisting the audio in the Chinese Standards Committee. That's a big player. They have pricing power. And we will work with them, and we will feed our understanding, discoveries, and input to assist in that effort. On the usage side, we like to be able to identify important performance metrics for cloud usage. So what's the big deal about that? We think that, right, as one of this morning's speaker mentioned, cloud is all about service. And the service level agreement is a very important model or document. At this moment, some people are reluctant to use the cloud because of security issues, and sometimes it's a fear of the unknown. They don't know what they're getting. Will they get the type of service they are used to in traditional data centers? If they are, then maybe a lot of people would be happy to use it. At this moment, there are no boilerplate SLA agreements like you do. Now, these days, I think it's easier, and especially for Hong Kong, people are more comfortable going out and plunk down millions of dollars to buy an apartment than to sign up for a cloud account. Because the system is set up so that there are standard contracts, standard models to follow, not for cloud computing. What if I lose IC design company? The entire 99% of the asset could be in one net list. What if they lose it? So we think that there may be a lot of value in testing, understanding, and maybe help formulate and evaluate SLA issues. Okay, next I'll very quickly talk about the cloud computing technology. Some consideration in adopting cloud computing. So certainly there are a lot of appeals. We heard a lot about that. But in summary, we see that some of these will stand out. It requires low capex, low entry fee, quick startup. And a big buzzword these days is big data. Huge quantity of data are being generated every second. They have to be managed, understood, processed, adopted, and integrated into work process. So cloud computing allows us to do that at low entry fee. The low entry fee would also spawn a lot more new businesses, people who are willing to test their ingenious ideas. They can enter the market very quickly. And when you have enough people like that, competition will drive progress. There are also concerns about cloud computing. The list, you've seen that many times. I won't talk about it anymore. SLA at the end is what we like to focus on. So our S3's cloud computing technology program summarized here. This is our current view. It may change with time. We like to promote cost-effective cloud usage, enable wide range of cloud-based applications. We like to support digital city living, and embedded in that term a lot of different functionalities: e-government services, e-consultation, voting, e-commerce, health, banking, smart homes. We like to be able to support big data creation, processing, and analytics, understanding what's in the data. So the audio mentioned that they have been offering public information for reuse, and this will help. We think that that's extremely valuable. Our objectives then of our program is to provide and/or develop local support for cloud service developers and users, cloud-effective solutions for cloud service providers, sector-specific platforms for developing applications, and also investigate, and maybe demonstrate some service business models, SAS service models. And we also like to offer a cloud-based appliance for computation and data analytics. We may not be able to, certainly we will not be able to do all of that ourselves, but so we very much welcome opportunities to work with partners in the industry and in government. Our early focus areas are listed here. In the area of cloud service provision, we will try to develop some cost-effective alternative management systems, especially focusing in areas of peering, multi-hypervisor, virtual cluster networks for private and hybrid clouds. The private cloud probably would never arrive. People who, in the financial sector, they have the money to burn, and they're concerned about availability and privacy and so on. So they're willing to pay a high price, so a public cloud may not be right for them. But for the other people, I think there's a good place for private and community clouds, and a cheaper alternative would be valuable. We like to develop some enhanced security storage solutions working with universities, digital forensics, assured deletion of VM termination, and certainly we like to evaluate different proposed standards, working alongside the government. And of course, we like to work with the industry players too. We think that usually those are vendors outside of Hong Kong. I may be wrong. In the cloud service usage side, we like to develop some sector-specific platforms. S3 does not have the mandate and cannot afford to do a lot of end-use applications. So we like to focus on the platform side. So those would be our initial focus. And going on next, we will focus more on tools for optimizing cloud operation, partners from any sector, to develop technologies that enable platforms, software, business process as a service.